So this is on page 19. Nikhil, you can beat us to it. Okay, so if there's a fraction, guys, by the way, look up here. This is A. Okay, that is A. That doesn't change. Right? Whatever's in front of the bracket. It's definitely not in general format, right? This is not general. So let's type this in. I use brackets. Negative 1 divided by 2. Close the brackets. Then I start a new set of brackets. X plus 4. Close brackets. X2. Don't forget that part. And then I go plus 2. But just make sure that when you go plus 2 that it doesn't add it to the exponent. So you got to go arrow sideways to come back down to the main line. That's what you should have. Let's hit graph now all together. Oh, I see my graph there. Will a zoom standard work pretty good here? I think so. So let's do that. Zoom standard, enter. Do I need to change my window at all? I would not touch it right now. To find the vertex, I'll have to press second, trace, min or max? Max, because that is the highest point. It's the maximum. Think of a hill. It looks like a hill, right? Otherwise, it's a valley. A valley, it's the lowest point, the minimum. Hill, it's the max. So you have to press max. So let's go ahead and find it. Second, trace, maximum. Mine is blinking right now to the right of the vertex. It doesn't work. So you got to go over to the left. Go over the hill to the left of it. Hit enter. Then go over to the right of it. Hit enter. And then enter one more time. And it is -4, 2. That's my vertex. It's exactly, right? You round to 2 decimals. If I round this one to 2, you know what? They just introduced this last semester with the grade 12 applieds. And almost all of my students lost half a mark because I forgot to tell them. You see how it's 4.000? The province says that technically that needs to be rounded to 2 decimals. I was so upset about that. I'm like, why didn't you tell us sooner? So technically, if it's 0.0000, you're technically rounding. So who knew, right? So just do that if it ever comes across. Okay, anyways. Equation of axis of symmetry. We have everything we need. This gives us the equation of the axis of symmetry. Okay? Just boom. Equation of the min or max. We have a max situation here. Oh, I shouldn't circle max, sorry, because the other ones may not be max. My bad. I will just indicate here. There's a max here. Y is equal to the y value of the vertex. There you go. Predict the number of x-intercepts. Where's the vertex? Above or below the x-axis? Above. Which way is it pointing? It's down, right? So it's going to have 2 x-intercepts. This one I'm not too worried about right now. Okay, you don't have to worry about this, but I will just say that vertex is above. A is negative, so it's going to cross it twice. Okay? Don't worry about that one too much. Next is the x-intercept. What do we do there? We let y2 equal 0. Second, trace, intersect. So we're going to go y2 is equal to 0. You have to graph before this works, okay? Graph. Then I'm going to go second, trace, intersect. I'll find this one first because I'm closest to it. Enter, enter, enter. So one of them is -2, 0. And the other one, just go over left or right arrows. If you go up and down arrows, you're jumping curves. You want to go sideways, okay? And that one is negative 6, 0. Negative 6, 0. We're good so far? I'll come around, if you work on the other ones, I'll come around and help you out. For the y-intercept, if you're sleeping, now I need to stay awake for this one. For the y-intercept, do I need my calculator? This is a trick question, by the way. Is this my y-intercept? Why not? It's not in general form. So you cannot say 0, 2. I'll prove it to you. How do we find the y-intercept? Second, trace value, x is equal to 0. So you're basically going to plug in 0 for x. That's what you're doing. Second, trace value. We let x equal to 0. There's my y-intercept. What is the y-intercept? 0, negative 6. See that? And I'm so, I so want to make sure you understand this that I'm going to go up here in these examples and I'll say not the y-intercept and a few exclamation marks. Just a few. Okay. So these are all not. This one doesn't even have anything, but it's 0, right? There's a 0 hovering around here. But these are not the y-intercepts because it's not in general form. I will add that to the notes. Not general. That's all I'm going to say. I think that should tell you enough. Okay? Let's keep going. What's the width of this curve? A is equal to 1/2, negative 1/2. So we will say wide because it's 0.5. Opening, it's down because A is negative. What's the domain of this one? Easiest one of all. X belongs to all the real numbers, or negative infinity to positive infinity. Yeah, if it doesn't tell you otherwise, this thing just opens up from negative infinity to positive infinity. The range, we need to understand which way it's pointing. Okay? And so because it's doing this, the highest point this ever gets to is 2. Okay? That's your max. So we'll say y is less than or equal to 2, or you go from negative infinity all the way to 2. Square bracket, round bracket. So the other ones are on you for now. Okay. Let's talk about domain and range real quick here. First of all, just a reminder, domain, we're looking at x values, like which x values are allowed in this situation, okay? The range is my y values. What y values are allowed in this situation. Okay, so let's just look at this first one. We know that A is negative. So we had a parabola that went like this, correct? Listen carefully to this part. When it comes to the x values, is there a beginning and an end? Is there like a limit at all? You would have to agree with me that this technically is telling me that it keeps on going towards the left ever so slightly, but it's going to keep on going to the left indefinitely. So how about we do this? It goes from negative infinity to positive infinity when it comes to the x values. right? So that's why we say that the domain, everything goes. You can go as far as negative infinity and as far as positive infinity. The graph will always exist, okay? So imagine you being on a car and you're driving along the x-axis and you keep going to the left, and you will look up or down and you all of a sudden see a graph there, okay? You always see a graph. The graph exists as far as you go to the right or to the left. So that's the domain. So we're telling our audience everything goes. In terms of sideways, you can go as far as you want. You'll always see a graph. When it comes to the range, it's a little different. How about we just come up right now? Does the graph exist past this point, past the vertex? Does it exist up here? It doesn't. So let's write this down. The highest this one goes is 2. That's the highest it goes. How about, and then it goes below that. So this is my y, okay? So what's below you when it comes to y values? What is as far down as you can possibly go? Negative infinity. So I don't know if this is going to help you, but I hope so. But the x is right now, I kind of made a little graph for myself based on the way it looks. Okay? And so for the y, only y values that are less than or equal to 2 are allowed. So that's the set notation. Interval notation, it's, can I say one more thing? It's kind of like you always read it from the bottom up. Bottom up. So if you want to state this range, the lowest you get is negative infinity, the highest you get is 2. And your domain, guys, technically, it's like you read a book. You go from left to right. Left to right, bottom up. Okay? So you always go from your negative to your positive, negative to your positive. Does that help? Yeah, question? I hope that helps. I have to interrupt you. At least I'm going to do the first 2, and the other 2 I will post. Okay? So this one right here. What was the coordinate of the vertex? Was 3, -6. Correct? The equation of the axis of symmetry is given to me by this. This one, A is positive, right? So we know that this is pointing up. So in this case, I have the equation of the min, which is y is equal to -6. It's given to me by the y value of the vertex. Watch this, guys. I know that because the y value is negative, I know that the vertex is below the x-axis, and it's pointing up. So 2 x-intercepts. Vertex below, A is positive. So we notice that if there's a negative, right, and a positive, that's going to result in 2 x-intercepts. The x-intercepts themselves are 1.27 and 4.73. Okay. The y-intercept itself is 0.12. You got to use second trace value for that. This is going to be a narrow curve because A is greater than 1. It's going to open up because A is positive. My domain for now, especially because I don't give you a graph, we are assuming that it just ends up opening up indefinitely. This one, let's try the trick that I just showed you here. For the y, especially for the y, for the range, we go as low as -6 and above it, right? So how about this is going to help you state it in interval notation. So you go from -6 to positive infinity just by looking at this. Or you can say y is greater than or equal to, greater than, because see how it's pointing up? -6. So that's how you state that. Okay? I think the last one may have a problem at one point. Let's write, I'm gonna write it down anyways. So here, let's do the last one. A, okay, is positive. So the vertex here should have been 7, 0. The axis of symmetry is just 7. The equation, it's pointing up, right? So this one has a minimum. So the equation of the minimum is 0. Predict the number of x-intercepts. This one has only one x-intercept, actually. And it's okay if you missed the prediction, that's fine. So the x-intercept is, lo and behold, 7, 0. I don't know if you remember, I talked about the 3 different scenarios. You have no intercepts. You have one intercept. That's when your x-intercept is also the vertex. Right? That's the only point it touches on the x-axis. Or you have 2 x-intercepts. The y-intercept is 0 as 68.6. Now, you may have had an issue with this. You may have had an issue with this. And I actually, now thinking about it, I'm going to take this chance to teach you how to get around that problem. What happened to my calculator? Oh, I gave, okay, wait a minute. He stole it. No, it's okay. I gave it to you. Okay, here we go. Let's type this in, all right? Just do it, just do it. There's a problem that I can see appearing. So I'm going to go 7. 7 divided by 5. I put that in brackets. And then it's, what's up with that t there? I don't care. We'll still type in x no matter what. Minus 7. It's minus 7 in here, not negative. x2. Okay, so let's graph this. It's a little off, so I'm going to go zoom 6. I'm going to reset my window. So what's the problem here? You see the vertex, you appear to see the vertex and maybe the x-intercepts, but we don't see the y-intercept. So I need you to chase the curve up. I'm going to go 50 for now. Still not good enough. I'm going to keep increasing my y max. I'm going 100 right now. And there it is. I went all the way to 100 up here, y max, to see this. Okay? And then you go second trace value, x is equal to 0, and there's the 68.6. Okay? So I adjust the window. That's what I'm trying to say. Adjust your window. If you don't see the point, chances are you're going to get an error message on your screen. Okay, you got to see it for it to be found. The width is a is greater than 1, because 7 over 5 is 1.4. So then that's what it is, okay? So this would be a narrow curve. Opening is up because A is positive. Domain is, I'm just going to stick with 1 right now. And here is your range, right? So we know that this is pointing up. We got the domain taken care of. What's the lowest y value this thing ever gets to? It's given to you by the vertex. The y value of the vertex. It's 7, 0, right? So 0 is the lowest this ever gets to, and then it goes up from there. Okay, so we will go either y is greater than or equal to 0, or you go from 0 to positive infinity. Okay, so that's also part of it. All right, so this is the important piece I wanted you to observe today, okay? I want you to observe something. None of these are in general form, right? Look at the vertex. Look at the vertex. Do you see these two values perhaps up here? 4, 2, 4, 2. Let's go over to this one. 3, negative 6, or there's a 3 and a 6, there's a 3 and a 6. There's a 7 and there's a 0 tagging along there. 7, 0, 7, 0. You see that pattern? What do you notice about the sign of the x value? If it's positive here, what is it out here? Negative. If it's negative in there, what is it out here? So it's always the opposite sign for the x value of the vertex. What about the y value of the vertex? Does that change? It doesn't change, right? 0 stays 0. This is honestly the biggest, this is what I wanted you to see today. So let's go to 15. And I want you to just look at the vertex form. This is called the vertex / descriptive form. We were talking about general a lot. Now it's the vertex form. So the vertex form tells us the direction of opening and the width and the number of x-intercepts possible as well as the vertex. Okay. So here is what you need to understand. Okay. I'm going to use two different colors here. When you notice that there is a bracket in there, just one bracket, okay, you know you're in vertex form. And so I would encourage you to have all of this down, all of this information down, okay? Where A tells me the width, just like before, and the opening, direction of opening. And the vertex, like when you have it in this form, you can actually tell me what the vertex is without a calculator. So this one just gets plugged in there, like if you want the coordinates of the vertex. And this one tells you the first part. However, what happens to the sign of this number when you bring it out into here? It changes sign. So in math, the way we indicate that is go negative h. Change sign. Okay. No, because, okay, this is why. If h is negative in here, and we plug it into here, this will turn into a positive. So that tells us that if this is positive, h is actually negative out here. Yeah, this is part of, so, okay, I'll do this. Just h. This sign doesn't come with us, okay? It's whatever h is, so h will have its own sign. Then it'll be changed here. So this negative is going to change whatever this ends up being. So if this is positive 4, this negative will turn it into a negative 4. If this is negative 4 and you plug it into this, that negative will turn this into a positive. So this negative sign changes the sign of whatever you bring out into it. Okay? So don't focus so much on that. This is just a general, but you got to change the sign of whatever that is. Okay? The bell is gonna ring any second now. So, I'm just gonna say this for your homework. 18 and 19, pages 18 and 19, okay? You can do that without this lesson. To be continued.